So I guess after the demo, which we've kind of seen, we have an idea in terms of how to go ahead and use the Do Azure Parallel R package and go ahead and start spinning our simulation in parallel on Azure instances. Now, I would want to kind of take it to the next level, and as I kind of mentioned earlier, that there are certain areas of improvement for Do Azure Parallel. I mean, I'm hoping that probably since this is open source, people can actually go ahead and start contributing in terms of how would you want to get around to support other parallel constructs like apply function, lapply, rapply, and sapply. The more interesting part is most of the machine learning algorithms which are there today to be used are not tuned to the point where it can actually be run in parallel. By that, what I mean to say, let's say I have a random forest which probably takes about 200 hours, and I would want to kind of get it to a point down to maybe about 10 or 20, and some parts of the code within random forest are iterative in nature, and some of it can actually be run with rewritten with parallel constructs. So I would want to kind of get the ML algorithms to be running in parallel, and we'll look at an example in terms of how to get around that. So these are the areas, broad areas improvement which I see in DoAzure Parallel. Moving further, how do we bridge the gap? So now, with the existing constraints that we have, and we would want to kind of use the parallel constructs. We would want to use what is available for parallel and do parallel at an individual instance level. I know I cannot probably use that straight off from Do Azure Parallel, but let's say I would want to maximize the instances in terms of using the number of cores per instance. I obviously have the mechanism at pool config.json where I can actually have number of instances, number of tasks run per instances. But that's again kind of getting to a point where I would be load balancing at a specific individual instance level and running this on multiple core. But however, I don't want to do that. I would want to kind of use the underlying features, for the parallel constructs and take it to the next level. Next, I would also, from an algorithm standpoint of view, the good news is that some of the MLR algorithms kind of use parallel map, and now you can actually get to point of parallelizing your execution of algorithms. So let's walk into the demo. So before I get into the demo, now how do I go about using multiple cores and parallel constructs in my R code straight off from Azure instance? Now it doesn't have to be that complicated. It's a pretty simple. So this is the same old function where we say do real parallel stuff, but only this time around I have started using the library parallel. I go about detecting the number of cores. Now, based on the number of cores, I go ahead and create a cluster, and means when you create a cluster, kind of the support which you have in terms of clustering is both fork and socket based. I won't go into the details of the clustering side of the story. Just a little bit more on the cluster. Here, the cluster is at the core level, but if usually in parallel, I can actually have clusters at an instance level as well. So something like an open Lava job scheduling can help me to do the same stuff. In that case, it's going to be competing straight off with Do Azure Parallel. But apparently, this doesn't support straight off the Azure instance. Here I've just put a number base is equal to 2, and if I basically want to export that number to run into individual cores function, and here so here's a function where there's parallel apply, and which calls the function which basically calculates the exponential. So, and this is just a kind of put out there just to kind of give you a sense that we have the number of cores out of each machine. So let's get into the demo. Okay, so first part of the demo, I'm just going to return the number of cores. So I'm not really going to be doing much. So let's go ahead and load this function with the memory. And all right, so come back to the demo. Sorry, it's a little bit of confusion here. Machine is here. Okay, so here we are back into the machine. So here at, I've loaded this function to the memory. Now I'm going to go ahead and fire off the corresponding method just to kind of get a sense in terms of the number of cores which are going to get sent to D2B2. So it's going to go ahead and start the job and wait for the job. So now the job's completed. I've got an int of number 2. So I have 2 cores which I can run my individual code onto these little machines. So now let's go to the point where let's see how the exponential function. So this function is actually going to be running it's a parallel apply. So it's a construct. So going further into it, kind of loaded that, do this, and now we'll just wait for the results to kind of come up. It's taking time. Yeah, we're done. So I can see 4, 8, 16, which is coming back from both. So it's kind of run. The iteration is given twice, so it's actually running of 2 instances. So this is what I get. All right, so coming back to the code, what's really happened inside the code? So what I have my R script, which is running out of my R session, but I've gone ahead and done a for each, which runs on individual Azure instance 1 and 2, and they load the parallel package, and then they go ahead and run the code on core 1, core 2, and so that's how I've gone to a 1 degree further level of parallelization. So this is taking it to the next level where I'm actually using the parallel package. Now, with parallel package, there are certain added responsibilities one is actually going into for, specifically in case of the functions which are actually getting loaded. Because if you have very large functions, you obviously want to have them loaded on a shared memory area rather than its own memory. So that it's all. So in the next talk, we are actually going to get to the point in terms of how do we improvise. What are the areas we look at in terms of caching and memory management from a parallel package standpoint of view. And subsequently, we'll close the session where we talk about MLR and parallel map, where we actually run a random forest on this kind of infrastructure.